that was my whole talk. That was great. Thanks.
Cool. Hi. Yes, I'm all of those things, apparently. Additionally, I'm Chris Bailey. I run the Triangle DevOps meetup group. If you guys are still not a member after normal, shout it out. It's meetup.com/triangledevOps. Also an organizer of this conference, and I'm head of DevOps engineering at a company called Advisor Engine that does analytics for financial planners. Cool, so my talk is about observability. It's I think one of the latest DevOps buzzwords. So starting things out, are there any, we have tons of cinematic references, but are there any car people in the audience? Like anyone that, okay, there we go, there's like cool, so if you don't know, this is a Formula One car, and it's the pinnacle of motorsport, considered by some. That is a multi-million-dollar device supported by between 50 and 100 engineers. They make changes constantly to it. They race weekly, so they do weekly deployments of new wings, new technology on the car, and they collect a ton of data. If this sounds familiar, it's what we all do on a daily basis. So there's a lot of parallels between how Formula One teams work and how DevOps engineers work as well. So to move on from this, yes. So when things go wrong, one thing to note about Formula One as well, these cars are incredibly fragile. They're made of carbon fiber and ultra lightweight things. And when an accident happens, it looks a little like this. And I've been on call and page enough to know that at 3 o'clock in the morning, I have that exact same body posture. So moving on from that, one of the major things with engineering, especially with a car of this level of performance, is the amount of data collection that Formula One does. And an absolutely incredible statistic. So if you guys know, they do race in the United States. They race in Texas. It's called the United States Grand Prix. An incredible statistic. 2014 US Grand Prix collected 243 terabytes of data. An incredible thing about that is we had a talk a little while back with a guy that ran a highly performant database, and he had all of the National Weather Association's data, weather data for the last 100 years, I believe it was, 150 terabytes. Formula One collects more data than the entire weather for the last 100 years in a weekend. So, an absolutely incredible statistic.
I think 2014 as well. Like,
yeah.
You have to imagine the data that you collect now.
Yes, it's staggering. Like, this is so much data. So moving on from that, to take a look here, this is what it looks like at the race. So you have a bunch of engineers who are on the pit wall collecting all this data. You can see the massive amount of screens that they have, constantly giving feedback to the driver about what's going on, making changes, looking at weather patterns. Down here on the left, you can see they track almost everything on the car, the angle of the tires, the heat, the steering angle, like tons of data. Up there at the top, that's a graph of a Formula One car literally doing a lap. They can provide that data back to the engineer, say where they're slow, where they're fast compared to other drivers, where they can pick up speed. So, absolutely astounding. But in a great, like, this is an amazing multi-billion-dollar sport, this is PayPal. So if you look, it's very similar. Actually, they have this huge command room. If you guys haven't seen this, this is their Observability Command Center at PayPal. One thing to note about this photo that's amazing is that 2-foot-tall lava lamp. Just as I was running through my slides, I was like, wow, that is a gigantic lava lamp. But same idea in that you have a bunch of engineers who are constantly monitoring the system and providing data back to the developers about how it's running, how it's looking, changes that do need to be made, and just looking at the general performance of the system. This actually is from my previous job where I set up an entire observability platform and did the exact same thing. So I sort of know what I'm talking about, but we'll get back to this slide a little bit later. So let's talk a little bit about observability. Observability is a superset of your monitoring, your logging, your alerting, Baron Schwartz, who is CTO of Vivid Cortex, came up with this amazing quote. Monitoring tells you whether the system works. I think every person in here who's a DevOps engineer has looked at some form of monitoring, right? Observability lets you ask why it's not working. And that's a huge distinction. So Nagios, those olden days where it was red-green, you walk by, you see it's red, oh, I gotta pull out my laptop, I have to look into this, right? But in modern day observability, we're looking at predictive trends, we're looking to see what's going to happen in the future, right? And be able to be more proactive than reactive. So again, this is from Twitter. Twitter coined the observability. They wrote a blog post, it's down at the bottom of the slides. And so it encapsulates everything. It encapsulates monitoring, alerting, and visualization. So that's your Grafana or Kibana. Distributed systems tracing infrastructure, which is fun to say. And then your log aggregation and analytics. So to look at this from a technology standpoint, your monitoring is going to be your Datadog, Prometheus, Icinga, alerting and visualization, again, Kibana and Grafana. Your distributed systems tracing infrastructure. This is something, as you can probably go talk to literally 2 or 3 companies on the other side of that wall, is a big deal. This is putting agents inside of your code, letting them run and helping for error tracking. So Zipkin's one, OpenTrace, Dapper, and then literally right through the wall where Chris Knotts is, OverOps, they do this as well. And then application performance monitoring, App Dynamics and New Relic. I think most people are pretty familiar with them. And then the log aggregation and analytics. Splunk being the huge player in this, Logs.io being a hosted ELK solution, and then the modern day EFK stack, which is Elasticsearch, Logstash, and Kibana. Fluentd. Cool, so what's the first stage to head down this observability path? The first thing is to literally instrument everything and collect a ton of data. Everything should be tracked. I mean, again, to go back to the Formula One statistic, 243 terabytes of data for a car. So when we're running multi-million-dollar systems, same idea. We should be ingesting a ton of data and literally monitoring all the things, alerting, logging. So the question always comes up, especially at the C-level, software as a service versus self-hosting. This, and I'm going to come right back to the slide, is this kind of question. Like, don't answer it. The proper answer to it is use what works. And one of the things that you see is, well, we've gone software as a service. We should take everything software as a service, right? So, okay, we use Splunk Cloud, then we should use New Relic, then we should use any number of other cloud-hosted providers. The truth of the matter is what I've found is a hybridized solution is probably the best, which is to both split it, your highly important production data, logs, metrics, all of that, alerting, might be best as a software as a service, right? The majority of them are already fully HA and DR, and they are ready for mistakes to happen, and they have a fully set up infrastructure to handle it. But an area where you get a ton of data, but it's okay that it's down for a little while, like development, where these metrics are hugely important to developers, but again, they're not going to cause you to lose money. That can be a self-hosted thing, right? You can bring that inside your cloud, bring that inside of your own infrastructure, host your own EFK stack, and then also use Splunk for your production data. I work in a fintech company where we have to keep data around for 7 years, so that's a lot of storage. So we split it actually between the two, which is, again, we use Splunk for our production data, and we have a guarantee from them that it's going to be around for 7 years, and then all of our development data on the back end goes through hosted service, or internally hosted services. So stage 2, the path to enlightenment. Man, I am flying through this talk. Yeah, so stage 2, the path to enlightenment is where it all comes together. So again, talking about monitoring from the perspective of just a bunch of screens or something that you occasionally tab over to. A good example of that is New Relic. People don't really look at New Relic unless there's a problem, right? But New Relic can tell you a lot, and this is where, to kind of pull on Lee's talk just a little bit, this is where you can begin to communicate with C-levels, is if you can show business value in your observability platform, and you can show that it is customer impacting, not from the perspective of, I have a CPU running hot, or like this machine is not looking too good, right? But if you can correlate your metrics of, here's my user flow, right? Here's the customer funnel, here's all of that, and be able to point to each individual part of that and say, here's how the system is running. When we have performance problems, we have a user problem, right? They fall out of the funnel, they click off the website, they don't care anymore, they're disengaged. That is the kind of conversation that you can have with a C-level and say, here's this huge monitoring observability, like we've put all this together, here's how it's affecting the customers. And here's where, when you start to look in DevOps for improvement, you actually get a really amazing roadmap in terms of what to fix next. Because the way that, in every organization I've ever worked for, the driver of DevOps is really like, they're a cost center. They're always considered a cost center. But when you can start to show the value of the improvements that you're making, that are, you can link, okay, this error fires constantly, right? And I see it over and over and over again. Well, if I go to a CTO and say, I see this error firing over and over again, it goes into a bug backlog, right, for the developers. But if I say, I see this error happening over and over again, and I watch a user drop out of the system, and I can track their IP address, I've never seen them again, like, that's a bad experience, right? That guy had a really terrible experience with the website, never came back. So to show this in the real world, that screen up in the top left, so each one of those screens, bar the far right one, but you can't see anyway, is a single application. So the company, which I will not name, that this picture is from, had multiple applications, some legacy, and then some pretty modern. Each one of the screens, again, is monitoring a single application all the way down the line. The far right one, the far two right actually are monitoring infrastructure, but coming back all the way to the left. So this is Grafana. We ran a pretty normal stack of using Telegraph as our collector agent. And we ran pretty normal stuff like New Relic and an EFK stack on the back end. But what you can see from this dashboard is the massive correlation that we're able to do between disparate systems. So from New Relic, we were getting throughput, response time, and then the errors captured by the New Relic agent, which is only one side of the errors that were being captured. Going down to the EFK stack, you can see additionally, we were getting a ton of log errors. So even New Relic didn't care about them. New Relic didn't see them. But the logs from the application itself were throwing errors. So on one individual box, pretty much one individual visualization, we're able to show both New Relic errors as well as log errors and correlate the two together, right? So we could see a spike in New Relic errors as well as errors from the logs. Additionally, HTTP response codes. Couldn't get that from New Relic, but could get that from the logs. So just parsing the access logs, being able to show like, okay, we have a huge spike in New Relic errors, and we see 500s coming in. And then finally, Telegraph. Telegraph is a lightweight agent. It's made by Influx. They're on the other side of that wall too. It's absolutely wonderful. Collects data, has a ton of plugins, has an amazing ecosystem around it. We were using those for system performance. So a little bit lower level than just CPUs. So this was a Windows shop. Sorry. But able to look at how Windows was actually performing. So beyond just I see my CPU utilization go to 100%, we were looking at thread counts, seeing how those were being handled, if they were dropping off, if they were staying very high, if they were continuing to grow without abandon, which happened multiple times, as well as the memory heap size. Was the .NET application cleaning up after itself? So coming in, setting up this platform was a huge win at the company. My actual boss that I did this work under is somewhere in this room. You were welcome to go to him and ask him how successful this actually was, but I think it was great. But we were able to go all the way to the C levels and say, this is like what I came in when I joined this team. This was our big initiative. And we were able to immediately sell the value. We had an application that we had just acquired that was incredibly bloated, didn't run very well, had massive performance issues. Using this, we were able to, DevOps themselves, I think we opened something in the range of 20 to 30 bugs just from DevOps engineers seeing this stuff, going to the developers, working directly with them, spinning out bugs, working through that, being able to report back to the developers the performance issues. The other big thing that was incredible about this is the amount of developer interest. So it was very fun. I ran around like a child on Christmas morning, and I collected developers, and I said, you guys got to see this really neat thing in our room. First of all, DevOps people love living in the cave, so when you have 6 TVs, you can turn all the lights off. Secondly, the second great thing is once we sold the value to developers, they wanted a screen in every single room, like all their different breakout rooms and hallways, all that kind of stuff. So not only did we have a C-level organization that was very supportive of it, we also had from the exact opposite direction, developers saying, how do I get this? How do I instrument my code? How can I send stats-D data? All of that. And so that was just a massive sell. So the pitfalls, and there are some, and this is kind of a, just be careful. So it is incredibly time consuming. We were a fully on-prem solution, so we weren't able to leverage cloud services, which means we were building Elasticsearch clusters, all of that inside of our own data center. That is crazy time consuming. I think from the moment we started this till that was probably around 4 to 5 months. We were iterative along the way with delivery, but like being able to correlate everything together really did take us about 5 months. And the good news is that we had an organization that was willing to give us the time to do it, but if you don't, it's going to stretch out even longer. The other big thing, distributed systems are incredibly volatile. A good example of that is Elasticsearch. If you can go hosted with these things, you should. Like AWS has one, Elasticsearch as a service. I'm sure there are others. But with something like Elasticsearch and etcd and timing on machines and everything like that, when it goes south, it goes really, really, really south. The engineer that built our Elasticsearch cluster, we had some problems with the underlying infrastructure, had to rebuild it over and over again, and it is really fun migrating 60 terabytes of data to a new Elasticsearch cluster 4 times. It's not. In fact, Elasticsearch to ingest 60 terabytes takes about 2 days. And then there is the cost associated with this. So you are building a lot of underlying infrastructure, or you're going to these software as a service companies, you're giving them their money, and it can start to add up. Again, the benefits are there, but one of the main things is there's probably 2 axes, right? There's cost and the return. You have to capture that as quickly of getting like the value of it way before those 2 intersect, or else you're going to get shut down. But the benefits, the impact to the business. So again, the more data that you can pull together and the closer that you can get your system metrics and your logs and everything to actually represent a customer going through your system, the better it's going to be. And it's a massive sell to everyone. Marketing people, product owners, everyone can understand when you say, this is impacting customers. Not at a level of, oh, we have an outage, there's a fire, at a level of, we're having 10% of system degradation that is affecting our customers at 20, 30, 40, 50%. They're dropping out of the funnel. They don't care, right? Their pages are loading in 7 seconds. The other big thing, and as a DevOps manager that I found massive value in, is that my engineers had a huge understanding of the data that was being ingested. So one of the things about going to a software as a service is there's a reliance on plugins or like, here's everything you need, right? You deploy this agent, we detect everything for you, and away you go. But when you're in the weeds like this and you are combing the logs and you're finding the log lines that really matter to you and to your business and that impact you, and when you're looking for the metrics, the key metrics, not like I have a dashboard of here's all my infrastructure and here's my CPU and memory, all that normal stuff, but hey, my application sucks at memory or garbage collection. That's a metric to look at. So what we really found was that everyone that was involved with this project really understood our application at a much deeper level than we ever would have just being DevOps engineers, like talking to developers. We were able to say to the developers directly, here is the parts of your code where we're having problems, and again, be able to spin out bugs. It was also great for war rooms, bringing people in when outages were happening. When you're able to correlate that amount of data, it makes it much easier than trying to find a needle in a haystack. Observability becomes a constant presence. This goes back to the request. So once you do this, it does open up, like everyone wants to see this stuff. And that goes all the way, especially in this case, went all the way to the C-levels where they wanted to be able to see this stuff. I have a fun picture on my phone of the CTO, like he would check metrics every morning, which is a gift and a curse. So depends on how much visibility you really want. And then additionally driving towards, headed towards product owners, marketing, things like that, headed towards Pendo integration, being able to actually see like correlation between all the way to the lowest level of infrastructure, all the way to the highest level of like your customer. And your developers become engaged. Being able to talk at the level that we were about how our system performance was affecting their application, how they were pushing, it's easy to say you've pushed crap code. Being able to say, this is the exact line of crap code that you've pushed, and here's exactly how it's impacting everything, and here's, let's fix it together, is a huge sell. Yeah, so cool. I don't know, I like this slide. Yeah, so anyway, that's it. Cool. I don't know how to end it.